Hello students, welcome to the lecture series on decimals and fraction. This is the first lecture on decimals and fractions. So, why decimal and fractions are important? So, decimal and fractions come into the picture when we need precision while measuring things. Okay, so what do we mean by precision, right? Let's say you go to a pizza shop and a full circular pizza is available there for 300 rupees. Okay, so you have 150 rupees. So, how much pizza will you get? Okay, in that case, you need precision. Okay, while measuring the amount of pizza that you need. Okay, so that's where decimals and fractions come into place. In this lecture, we will be learning the concept and type of problems on decimals and fractions. Okay, so as we have encountered with integers, whole numbers, and natural numbers, we will now learn decimals and fractions, and they are actually interconnected in mathematics. Okay, so decimals extend them by introducing fractional parts. So, what do we mean by decimals? Okay, fractional part means the part with of the form P by Q. Okay, wherever you see something written of this form, okay, P by Q, that is 2 by 3 for example, or 6 by 9 or 1 by 2, these are fractional parts. And observe here that Q must not be equal to 0 in this case. Okay, if Q is equal to 0, the fractional part is actually undefined. So the number written of this form, that is P by Q, where Q is not equal to 0, is called fractional number. Okay, so what do we mean by decimal numbers? You must have seen numbers like this: 0.36 or 1.69 or 1.99. Okay, this kind of numbers you must have seen somewhere. Okay, these are called decimals, where there is a 100th place or 10th place. Okay, and there are whole numbers here. So these kind of numbers are called decimal numbers. Okay, decimal numbers. Okay, so fractions actually represents a part of a whole. Okay, like the example I gave, a pizza. Okay, let's say you have a pizza down here. Okay, so this is a whole, one pizza. Okay, and fractions represent a parts of whole. Okay, let's say you have two parts. I have divided it into 1, 2, 3, and 4, and you have these two, let's say. Okay, so you have 2 by 4. Okay, this is called the denominator and this is called the numerator. The total number of parts, equal parts, is actually called as, or is written at the denominator. Okay, and the parts, equally divided parts you have, is called the numerator. Okay, so in this way we can diversely express the quantities. Okay, how can I say that I have like half of a pizza or 2 parts out of 4 parts of a pizza? I can write that I have 2 by 4 parts of pizza. Okay, so what are fractions? It comprises of a numerator, just like I told you, that is P by Q, where P is the numerator. This is the denominator. Denominator. Okay, so it comprises of a numerator and a denominator linked by a fraction bar. This bar is called as the fraction bar. Okay, so this is also called the as the upper number, to simplify things, and this is also called as the lower number. Okay, so the numerator signifies the parts under consideration or the number of parts you have. Okay, here in P by Q, you have P parts you have or considered, and Q is the total number of parts available. Okay, so the numerator signifies the parts under consideration, while the denominator signifies the total divisions of the whole. Okay, and mind here that the total divisions are actually equal, like divisions are of equal proportion. What do you mean by that? That for that pizza example, let's say, okay, I have a pizza and I have divided it into 4 parts in equal parts. Okay, this part, this part, this part, this part. These are all equal. Okay, 1, 2, 3, 4. All these parts are actually equal. I haven't divided this as like this. Okay, like this, and then this. Okay, 1, 2, 3, 4. This isn't divided like this. Okay, total divisions actually signify the equal, like all the divisions are actually equal divisions that they have equal proportions. Okay, so for instance we can see that 3 by 4 or 3 by 4. Okay, here is the fractional bar, fraction, numerator. What it means is you have 3 parts. Okay, and 4 means total 4 equal proportion available. Okay, so it represents 3 part out of 4 equitably divided proportions. Okay, equitably is to be noted here. Okay, that is equal proportion. Okay, here 3 is the numerator and 4 is the denominator. So we saw an example. Okay, so let's now jump into the types of fractions. Okay, so what kind of fractions are there and which are important, which are not. Okay, let's see each one. Okay, so the first kind is proper fractions and the second one is improper fractions. Okay, we'll see what proper fraction is, what improper fraction is, and what is the difference between these two. Okay, we'll see. So, and what are mixed numbers, what are equivalent fractions. Okay, what are mixed number, equivalent fractions, like fractions, unlike fractions, difference between these two. Okay, and proper equivalent fraction, improper equivalent fraction, and the difference between these two. We'll see each one, okay, in detail. So let's explore the first part, that is the proper fractions. So these are fractions where the numerator is smaller than the denominator. So we know that this is of the form this p by q, where q is not equal to 0. Okay, otherwise it will get undefined. So the fraction where the numerator is smaller than a denominator. So if p is less than q, this implies that this is proper fraction. Okay, and if q is less than p, this is not proper fraction. Okay, so proper fractions are always less than 1 because p is less than q. That's what it means is you have q equal proportions available, out of which P you have only P numbers of it. So P is less than Q. So what it means is you have Q number of equal proportion availables, but you have only P number with you. So P is less than Q. This implies you don't have a whole. Okay. So the proper fraction is always less than 1. Okay. So for example, 1 by 2, 3 by 4, 2 by 7. In this case, 1 is less than 2. In this case, 3 is less than 4. In this case, 2 is less than 7. Okay. Whenever P is less than Q, this implies that proper fraction. Okay. So let's see what improper fraction is. So these are fractions where the numerator is greater than or equal to the denominators. Okay. Either it is greater than or equal to. So if given is P by Q, this is fraction, right? And Q is not equal to 0 with the condition that Q is less than P. Okay. Q is less than P. Then this implies that this is improper fraction. Okay. So if this is improper fraction and if P is equal to Q, even then we can also say that this is improper fraction. As while writing this in decimal form, we can see that P by Q is greater than or equal to 1. Okay. These two cases imply this. So we can easily say that if in decimal form P by Q is greater than equal to 1, we can say that this implies this is improper fraction. Okay. So there are several examples like 2 by 2. In this case P is equal to Q, that is 2 is equal to 2, and 3 is less than 7, 4 is less than 11. Okay. So what is the difference? The difference is if the decimal in decimal form, if P by Q is less than 1, this implies proper fraction. And if P by Q is greater than equal to 1, this implies that improper fraction. Okay. So let's see the third type of decimal and fraction. Okay. So these are called mixed numbers. Okay. Mixed numbers are a combination of whole number and a proper fraction. For example, you can see here that we have a whole number down here. Okay. We have a numerator, a fraction bar, and a denominator. But what we do have here is we have a whole number as extra. Okay. This is a whole number. Okay. We haven't seen this one right now, till right now. So what it signifies here, we will see next. Okay. These are called mixed numbers. Okay. Where you have also a part in the fractional part, that is whole number. Okay. So what is equivalent fractions? So equivalent fractions have the same value but have many different numerator and denominators. So equivalent fractions are what? They have the same value but may have different numerator and denominator. So for example, here we have 1 by 2, that is actually equivalent to 2 by 4. Okay. So these are nothing but equal. Let's say like you have a pizza. Okay. You have a pizza and you have divided into two equal proportions, that is proportion 1, proportion 2. Okay. And then you have another pizza. Okay. And you have divided into 4 equal parts. Okay. So 1, 2, 3 and 4. And out of these 4 you have 2. 1 and 2. And for example, that 1 by 2. Okay. You have 2 proportions and you have 1 part with you. Let's say you have the second part. You can see that these are actually equal. Okay. So this is how we will say that the two fractions 1 by 2 and 2 by 4 are equivalent. Okay, if P by Q is equal to R by S, but P is not equal to R and Q is not equal to S. And note here that Q and S are actually not equal to 0, otherwise it will be undefined. Okay, so if P is not equal to Q and Q is not equal to S, okay, and but P by Q is equal to actually R by S, we can say that these two fractions are actually equal or equivalent. Okay, so what are like fractions? Okay, so like fractions may have the same denominator. For example, 2 by 5 and 3 by 5 are like fractions. Okay, so what are the condition is P by Q, and let's say another one is R by Q, where Q is not equal to 0. Okay, so in this case these are called like fraction, as both have the same denominator, that is Q. Okay, so the denominator is same, imply this imply like fraction. Okay, so what are unlike fractions? Just the opposite. Okay, if you have P by Q and you have Q by S, or say R by S, where Q is not equal to S. Note here that Q comma S are actually not equal to 0. Okay, otherwise it will get undefined. So if P by Q and R by S and Q is not equal to S, okay, these are two fractions, then we say that these two are unlike fraction. Okay, so let's see the seventh kind of decimal or fraction, that is proper equivalent fractions. Okay, these are equivalent fractions, like equivalent by what, like 1 by 2 and 2 by 4. We have already seen that these two are equivalent. How? Because they represent the same amount, okay, in precision, where the numerator is smaller than the denominator. Okay, if P is less than Q and P by Q is equal to R by S and R is less than S. Okay, where Q comma S is not equal to 0, and you know the reason why this must be not equal to 0. And with these conditions, okay, we'll say that this is proper equivalent fraction. So let's see the eighth kind of equivalent fractions or decimal or fraction, and this is called as the improper equivalent fractions. Okay, so these are equivalent fractions where the numerator is equal to or greater than the denominator. So we have P by Q that is equal to R by S, and Q is not equal to S. Okay, P is not equal to R. Okay, and Q comma S is not equal to 0. You know the reason why. Okay, so this is how we get equivalent fractions. Okay, so but improper equivalent fractions means the numerator, that is P, must be greater than or equal to Q. So for this case it will be like R is greater than or equal to S. For these three conditions, 1, 2 and 3 conditions, what we can imply is this is called improper equivalent fraction. Okay, so for example 5 by 2 is equivalent to 10 by 4, as 5 is not equal to 10 and 2 is not equal to 4, but 5 is greater than equal to not equal to greater than 2, 5 is greater than 2 and 10 is greater than 4, and 5 by 2 is actually equal to 10 by 4. Okay, So we have condition 1, 2 and 3 fulfilled here. So we can imply that this is improper equivalent fraction. Okay. So what are decimals? Let's explore them. So a decimal is a numerical representation that actually includes a whole number part and a fractional part separated by a decimal point. So you can see right here 6.3. So in 6.3 you can see that this is the whole number part. Okay, just before the decimal point, that is this is called a decimal point. Okay, so before the decimal point, the number we say that is the whole number part. Okay, and there is a decimal part. After this decimal point, all the part that we have is called as the decimal part. Decimal part or fractional part. Okay, so here is another example, that is 0.3. Here the whole number part is 0. 0 is the whole number part and 3 is the fractional or decimal part. Okay, here you can see that this is actually divided by this decimal point. Okay, before the decimal point we have the whole number part, and after the decimal point all that we have is called the fractional or decimal part. Okay, so let's see what types of decimals are there. So types of decimals is actually two. Okay, the first one is called the terminating decimals. Okay, and the second one is called non-terminating decimals. Okay, so we'll see what is the difference between these two. And actually the second part, that is the second type, non-terminating decimal, is further divided into two parts, that is non-terminating repeating decimals and non-terminating non-repeating decimals. Okay, just mind your terms here, that is non-terminating repeating decimals and non-terminating non-repeating. Okay, here it was only repeating, here it is non-repeating. Okay, we'll see the difference between these two decimals. Okay, the second kind actually of the second part is also called as the irrational numbers. Okay, we'll see each one, okay, in detail. Let's see the terminating decimals. So these are decimal numbers that have a finite number of digits after the decimal point. So if you have a decimal number that is p dot q r s t and some parts here and then z I say. Okay, so you can see that there are finite number of terms here. Okay, finite, fractional. So this fractional part is actually terminating. After that z there is nothing. So this is called terminating decimal. Okay, here for example you can see that 0.25, after the decimal point you have only two terms, that is 2 and 5. Okay, again here after the decimal point you have 7 and 5 and nothing else. Okay, so that's why we can say that these are terminating decimals. So what are non-terminating decimals? These are decimal numbers that do not have a finite number of digits after the decimal points. Okay, the number of digits that are actually after the decimal points are not finite. Okay, so it is also, let's say an example. Okay, let's see p dot q r s t and so on, so on, so on, so further, so on, that we can't have finite number of digits down here. The digits are just going on and on and on and on. Okay, so these kind of numbers are called terminating decimals. Okay, these kind of decimals are actually further divided into two parts, that is two kinds, that is non-terminating repeating decimals and non-terminating non-repeating decimals, that is irrational numbers. Let's say each one in detail. Okay, so the non-terminating repeating decimals are those decimals that have a repeating pattern of digits after each decimal point. Like let's say for this example 0.333 dot dot dot. So what it means is 0.333, then again 3 3 3, and 3 is actually repeating itself. Okay, so this is also represented as 0.3 bar. Okay, so here you can see that the second example 0.1428571428857. Okay, so if you see these digits after the decimal points 14287 then it is actually repeating again. Okay, so these repetitions are going on and on and on and on, so we can actually write this as 0.142857. Okay, and put a bar on it, but it means is actually equal to 0.142857. Okay, then again 14287, then again 14287, like this it will continue forever. Okay, that's why we use this bar symbol here. So let's see the second type of non-terminating decimals. Okay, so the second type of non-terminating decimals is non-terminating non-repeating decimals that are called irrational numbers. So these are decimal numbers that have an infinite non-repeating sequence, so you can't find a pattern right here. Okay, for example you can see here you can't really find a pattern. Are you seeing 1 4 being repeated anywhere? No, right? Or 1 5, nothing, right? So for example pi is down there and e is down there, 2.71828188284. Okay, let's just see here. Okay, 18 is repeated again, but after that there is 2. Okay, it is also repeated, but then 81 is there and here 84 is here, so the pattern not found. Okay, and the number of digits after the decimal point is actually not finite. Okay, so we can say that this is non-terminating non-repeating decimals. Okay, so